Alright guys, I just want to go over to start explaining my process with my experience with Haltech, the install, and what exactly were the troubles I encountered. So to start with exactly what I'm using, I got an Elite 2500 and paired that with the 1500 Mazda Miata NB plug-and-play adapter harness. I'm running an '01 NB VTC Miata, mostly stock, just intake and exhaust. Let's go with that. The reason I went with the 2500 is because it's indicated up to an 8 cylinders. Basically, just has a bunch more inputs and outputs, including 4 more ignition, 4 more fuel injector, so that I can assign them to whatever I want. It's just more versatility. That versatility is going to bite me in the ass, but I'll go over later why. The actual connectors on the adapter harness plug and play are compatible. They're actually pinned out for all of the pins that are in the 2500, including the actual 4 injector and 4 ignitions. They're just not used, but they are physically pinned out and run to the back of the adapter harness. Let's go over exactly what I bought along with this, because I did get a IO box expander, a wideband, and a CAN bus adapter for additional CAN bus extensions.
All right, so this is the setup. So 2500. These are the can high low. I need to get a Deutsch 4 connector to pig pigtailed so I can attach here with the 12 volt out and ground. These two, this is an extra ignition out. So basically, if I need another output signal, these two are my drive-by-wire 1 and 2. So these are going to be used for that. I have my wideband single connected straight to. Once I get the Deutsch connectors, I will connect this. I don't think I'll have this ready by the weekend, but that's fine. I can still use this connector. Once I have that Deutsch connector, I will then connect this. So it'll be harness to this, this to this, and a spare one for my IO12. When I bought this, I hadn't bought the ECU yet. I got this second hand for a really good price. Chances are I'm not going to need it, being that I have the extra inputs and outputs from the 2500 versus the 1500. We'll see how it plays out, but that's how it's sitting right now, and that's how it's going to pretty much stay.
Just wanted to show you this. This is the pinout for the harness. Following this, I'm going to show you exactly what pins and the process of assigning the pins due to the fact that this is a 2500 with more pins than the 1500. So just wanted to explain why these pages are important, and you're definitely going to need them if you use this plug and play hardware.
So the one bad part about this is that these harnesses to repin this end is really hard and obnoxious. Haltech has a good do-it-yourself on it. It's just annoying. This side to repin takes about 5 seconds. Super easy, very convenient. The annoying part is if I do the easy side, I lose my color coordination on my software. Does it really matter that much? Probably not. So I'm going to try to do it the right way. But there's a good chance I'm going to get frustrated with these connectors because they suck. And I'm going to just swapping out, repinning on this side. And the color coordination on the software won't match. But it won't really matter being that I'm the one actually working on the car. So modifying these, too much work. So I just reassigned the pins on this. Unfortunately, that means that my Haltech's built-in color coordination is useless, but it doesn't really matter. I use paper anyways. So I go off of, the B1s, B2s, B3, B4, B5, which is the B connector, not really the wires. So going on that note, because I have a 2500 versus a 1500, I have a bunch of extra inputs and outputs. So you can see factory, it uses my two drive-by wires. In this case, I could redefine the drive-by wires. So drive-by-wire 2 for the battery light got swapped out for ignition 7 input, my B17 instead of B26. So, which is what I did. I just undid the pin and then repinned it. These extra ones um, are unpinned and going to be left unused. I have an entire 2500 universal harness that I'll end up using to adapt slash reallocate the pins for so that I can correctly set up my CAN bus system and all that stuff.
All right, guys. So I want to go over what I did and how I got to a running tune from where I started. So let me start from the beginning. Assuming you've already downloaded the software, my recommendation is anyone before buying Haltech, download the software. It's free. Open it up, look at it. If you feel horrifically overwhelmed after watching Haltech's free on their YouTube, their guide on tuning, and they do a good superficial explanation. If you still feel massively overwhelmed, either find a friend or do a lot more studying before dropping the money for this. Okay, with that said, that's how I opened it. File, open, base tune. Okay, there's a massive folder you'll see when you go to open base maps. Ignore these are mine. Base maps, everything's here. You can go to Mazda, MX5, and everything's here. You're gonna see there's 750, 1000, 1500s, 2500s, and 2000 series. I have a 2500 Mazda VTC, blah. That's what I opened. All right. This is what you start with. Depending on what you're going to do and what you know your objectives are from the get-go, determines what modifications you need to make to this. I spent, I want to say, 6 hours assuming that this base map was perfect. I had a lot of help from the Haltech community on Facebook. They were able to help me solve one massive issue, which was simply this guy right here. Where is this little muffler? This. When Haltech wrote this software, it was on their ESP system. So it was done on, where's the old, this software. Since then, this is the new software. This is the better software. But when Haltech wrote all of the maps, they wrote it for Haltech ESP. When they exported this and made it compatible with NSPs, this for some reason switched on. So after going back and forth for hours, thinking I didn't have Spark, re-going over the wiring harness, over the maps, over the uh, trigger sensor, for the engine configuration, all of that. Basically, what ended up happening was this. It should be off. Or at the very least, put to momentary. Currently, I have my setup on momentary. This is the ignition switch. So this is not necessary in our case for our Miata on an NB platform. Don't know about the NA. Can only speak for NB. It does not need to have a sustained switch for the ignition signal. I leave it on momentary, so when I turn the key, send the ignition switch type, the signal output shuts off. Because what happens if you leave it on switch while you're holding the key on crank, it's sending the signal. This is supposed to be a single pulse signal that tells everything turn on and then lets the starter crank. Because of our car, I can turn this off theoretically, turn the key, the starter will still crank, start the car, at which case it'll trigger the main relay to just keep everything on basically. This is more like if I wanted to build some elaborate security system into the Haltech software. Anyways, there's a lot you can do with this. None of it's relevant to us. So I'm gonna switch it to momentary. Actually, I'm gonna switch it off. No, momentary. It's fine. Then we're gonna go into the. So that's one major thing. The other thing is here on generic outputs, you can see we have VTCS. I'm deleting mine. You don't need to physically delete it to turn it off. The flaps by default stay open and they are regulated off from there. So depending on what you're doing, my recommendation is to just until you physically delete it, like I haven't physically deleted mine, that's maybe I'll do it tomorrow. What I would recommend is for you to just flip it off and you'll see why. The next thing is, again, this is what I have on my car setup. Thermal fan. Thermal fan 2 is AC. It's the second fan on the passenger side if you are a left-hand drive car. I have mine hooked up so that when my primary relay goes on for my radiator, it triggers the relay for the second fan to turn on the thermal fan. So technically, I only am running one controller for the thermal fan, which is why I deleted this. That was left off. There's a lot of arguments as to why you want to leave this on. So AC turns on, this turns on, but regardless, you turn it on to monitor to regulate coolant temperatures. So I just have everything turned on, both fans. More is better, whatever. Now on free sensors. So by default, Haltech gives you a wideband sensor pre-built in, like programmed in, assigned to the CAN bus system and our narrowband, our factory narrowband. This I deleted. So I bought a wideband box, as you saw earlier in the video, and I deleted it. This, so now I have a wideband only. So bye. Next, if you have wideband, at this point, if you didn't have a wideband, you could just leave this on, whatever. Car will start. Crank it, plug it in, car will start. Depending on what you're doing, and for me, what makes Haltech best is it's self-learning. I'm gonna say self-learning. The proper term is short-term, long-term fuel trims. If you already watch Scotty's videos and Haltech YouTube page, you'll see he already went over this, VE maps, map pressure, all that stuff. I'm not gonna go over that because that's beyond me. I understand it enough so I can use it, not enough so that I can teach it. They teach it better. Side note, if you really want to learn about this stuff, go to Evans Tuning. Pay the subscription. His stuff is phenomenal. Yes, it's on the ESP software, but that's just the interface. The actual information, the tuning method, it's all the same. I know it's pricey, but even if you're gonna get this pro tuned later down the line, it is worth getting this so you can learn what the hell your tuner's doing. And you're not always gonna have a tuner next to you on the racetrack or on the road or wherever you are where you need to make modifications, where you have hiccups and so forth. He has the Mega Squirt Miata tune. Great for learning about the Miata if you're turbocharged or supercharged. He has both programmed in. To learn about tuning NA applications, even though this isn't a K series, his K series all motor is so comprehensive. Basically, you can apply it to any naturally aspirated four-cylinder variable cam engine. All right, going back to the software. You can crank here. Now, I'm gonna pull, I already have a second Haltech opened up for what I changed. So this is a more accurate representation of what is my car's currently running. As you can see, I'm not working on my laptop, I'm working on my desktop. So I exported it to review, named it, threw it up here. Now, for the sake of education, I'm gonna put this up. I'm gonna say pull a comparison table so I can look at, actually no, I'm gonna reopen the base map before I made those little changes. And now I'm going to open a base map for you guys to look at. So base No, that's the base map, and now I'm gonna pull up what I'm actually running in the car currently for comparison. So I want to see how much stuff I needed to change before I got to where I was like, okay, cool, I'm fully functioning. So, um, purple is things changed. What I'm running currently versus base map. Um, this comparison chart also sometimes gets funky because again, if I'm comparing it to the base map has random things that this doesn't. I don't know why. As long as this says the correct engine, ignore what happens down here. Don't touch this. The only reason you're touching this is if you've aggressively modified the factory engine. If you shaved off the deck, if you've for some reason your top dead center is not the same as top dead center from factory. If you have a flying Miata increased teeth count, so on and so forth. Throttle position. Mine is already calibrated. This is things so on my software I already calibrated my factory throttle body. This doesn't know that. This thinks I just did something different. My wideband. Obviously my other wideband, my proper wideband has already been calibrated. This hasn't been. Fuel tuning. Um base pressure. So as we all know, the MB runs 60 psi. In other countries slash NAs, they ran 43.5. Not really sure why. I'm gonna figure that out. But Haltech has their program to 43.5. So you either have to change this to 60 if you're running an MB and you don't have a fuel pressure regulator, an aftermarket one that's adjustable. Now you can run this at 60 and then allow once we get to the O2 controller, allow the ECU to realize it's running rich. It'll take it off the short-term trim, get you your right air fuel ratios, and then what you can do is you can just hop over to the long fuel trim, apply the changes, and it'll learn it. It's not the end of the world. Or if you have an adjustable fuel pressure regulator, you can drop it to 43.5. I haven't decided what I'm going to do yet. I'm probably just going to drop it to 43.5 simply because that's a industry standard fuel pressure. You don't need 60. I suspect Mazda just jumped it to 60 because they didn't want to change injectors because it was more expensive to change injectors than to increase the fuel pressure when they switched to the VTT system and realized that they were making more horsepower and they needed more fuel, so they just upped the pressure. Fuel pump. Um, okay, so this is different. My fuel pump pressure is different. Remember how I showed you in another video how you could reapply the different cables for different functions? That's what I did here. So what I did was I compared the two, but because I used different outputs for different things, and I reassigned the pins. I physically disconnected and reconnected the pins on the harness for that reason. Now, we're just gonna leave that as is. Go for there. Um, again, I just had to reassign them for different functions. It's normal. Yeah, on my system, evap is off. I deleted my evap system as well. Ignition switch, alternator, base. See, it says like there's changes. Um, yeah, whatever. I reassigned the battery light, reassigned the check engine light, deleted VTC on mine, and on mine I have, oh, so on mine, on base it's main connector, on mine it's main and aux connector. Reason why is I haven't hardwired in my CAN bus system yet for this. So I just want you to see that yes, this is a plug and play system mechanically. There will be some modifications to the software that you're going to need to make just to get the car running and depending on what you're doing. Now, in my case, I'm gonna get out of compare mode and I'm going to, am I in my right folder? No. I'm gonna hop over to this program, which this is my currently running software, and I'm gonna explain what I'm doing here. So, why the fuck is this so tiny? Anyways, so my O2 control is set to wideband. This stuff you can pretty much leave normal. If you have emissions issues, you have to change this to 1. Again, there's a better video online explaining why you want your target to oscillate for the catalytic converters. I don't, because I don't care about emissions. Long-term field trim would be enabled, la blah, and that's basically it. You can leave most of this the same. So their recommendation is long-term field trim, run it a little rich, let the short-term field trim subtract. It's better to be safe than sorry. It's easier to take away fuel than it is to add fuel when you're at 6,000 RPM and you're on and off throttle with transient throttle response. It's easier to run rich and deduct than to run lean and add. Once this is on, you hop over to your base tune, da, 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 and open your long term actually. And you have this. This is the changes that will be applied once you're there. So when you're driving around the car, this will propagate. You'll see adjustments, either plus or minus values through your map sensor. Because again, this is VE trained fuel control, not throttle to RPM response. This is volumetric based off of load and map pressure. So that's that. Once you've driven around, you hit apply, it'll apply this to your base map. It'll make the changes across this, and then that's how the ECU learns. When you're in long fuel trim gain, this is what Haltech has factoring. If you watch the educational videos, even Haltech says your values should be a little bit more elaborate than this. Um, Also, again, if you watch Evan's Tuning Academy, there's a lot to learn from that regarding long-term, short-term fuel trims and how you want the ECU to learn. Let me open up the one that well, I'll open it up later, but actually I'll show you how I did this. So, table access, let's enable RPM, and let's say 1,000, 2,000, 3,000, 4,000. That's easy enough. And let's insert column. Insert column. Let's go. Let's yeah, insert column. I meant to do minus 13.4. All right. RPM vacuum manifold, and I want to throw another one here. All right, that disperses it out. So normally daily driving occurs over here. Fun highway merging slash spirited driving slash track occurs up here. So higher manifold, higher RPMs probably occurs this way. So you have here, 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 more volume. The less data points you have, the more you can trust them. Why does that not make sense? When you're driving down here all day long, 45 minutes both ways to work, you're going to be gathering so many data points that if you teach the car too much about this lower end stuff, it's going to be constantly fluctuating your fuel trim. Once you have this down, it doesn't constantly need to be learning. So that's why the trim gain is lower. You'll see this on the teaching software that Haltech has up. They have more stuff here, so it's usually not this elaborate. So it's usually like 1, 2, 3,000, and then everything above it you can trust. Basically, when your car's warmed up and you're spirited driving and you're at higher RPMs with higher loads, you're getting less data points, which means that those data points are more trustworthy. they won't be contradicted by other data points constantly, by variables like, is it hot outside? Is it cold outside? Is the car finished warming up? We drive our car around to work before we even finish it, letting warming up to full 190 degrees on the coolant, for example. That's where this is all at. This is going to get constantly contradicting data points. Best part is to leave this around 30. This stuff, so say you're at high RPM, you let go of throttle, and you're in vacuum. This stuff can be more accurate. So let's say 50. It can learn it quicker. And then this I want 60, and by the time I get to wide open throttle, I want close to 100%. So I want it to trust everything beyond this point. Now, if I'm at low RPM and I'm at high load, it means I'm balling or I'm just going ham. So I'm going to level these out just to give you guys an idea of what remotely this would look like. And the reason for this is, there you go. So this is more in line of what you want. So as you have higher load and higher RPM, the computer is more aggressively learning those parameters, those values, those fuel trims, and then applying it to your short-term fuel trim map, which it'll then, when you're ready, apply it long-term. Um, these two are what I was talking about. So running, do you want the engine to learn before the cars reach full coolant temp, things like that? That's up to you. Again, a lot of this you need to use your own discretion. I don't know how to tune well enough to teach you guys. I'm just saying these are what the changes I've made to get to where my car is running smoothly.
All right. So next part, after explaining to you guys the software end and what I bought and how I set it up, I'm gonna go over the install or try to explain the reason behind the madness. First off, my garage is a mess. If you see the mess, just ignore it. Okay. Explaining to you guys how versatile it is and how I ended up deleting the EGR and the EVAP and the VTCS. The benefits slash harms are, I don't even know what harms are. The benefits are you're simplifying the system and you're just cutting out unused wires. Now, all of those pins, like I showed you, are already pre-built into the system. And let me show you where everything is. No, it's not mounted. This is not final. Yes, it's just sitting there. Get over it. So, unplug the factory ECU, plug it into the adapter harness. It needs a 12 volt and the wideband. The wideband I ran through the firewall. I'll show you down the other side. And right now that's just sitting underneath here, which is connected to my Haltech there. And voila. All right. I fed it through the now ripped up and gunked up grommet down there for my wideband on my manifold. Challenges are pretty extensive with this. So, you saw the issue with the spark. I was going crazy over this, had nothing to do with the hardware. It was that one setting. Aside from that, I do have this converted to a fuel return system. Now, I was running factory 60 psi off of the fuel pressure regulator, radiant fuel rail, blah, blah. Goes back. It's actually properly plumbed up and everything. The base map on the Haltech is actually designed for 43.5. I believe the MB2s in the rest of the world, especially Australia, where these are tuned from, still kept the 43.5 psi instead of the 60. I don't know the details, but if I ran 60, I ran rich. The moment I dropped it down to 43.5, everything ran fine. So I can instantly tell that the car was tuned for 43.5. All right. The factory boost sensor slash map sensor thing, this guy, I couldn't find proper calibration parameters for it. There was like three different contradicting volts for the absolute pressure was and the max map pressure that they could take. So instead of guessing, and I ended up grabbing a K24 Omni 2.5 bar map sensor. I cut the factory map sensor off and attached the pigtails to that. This has very precise linear calibration parameters, which was great for the Haltech. I just took it and went great. A lot of these vacuum lines are being, I need to get cap off fittings and blah, 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 and step down adapters. I know, it's ugly. Just let it go. I did end up deleting the EGR evap system, as you've noticed. So there goes the controls for it and everything. The reason for that is, so the connectors are still here. And so is the narrowband connector right here. The convenient part is that all of this plugs back still to the ECU. So all of these connectors are connected somewhere to the ECU's adapter harness. My goal, and if anyone's been following me online, is I'm going to be converting this to a drive-by wire using a BRZ throttle body. I've already confirmed fitment and everything. It's just a matter of actually uninstalling this, installing it, running the wires, doing all that, attaching a drive-by wire pedal from K-Power's adapter for a Honda Fit pedal. Have all of it. It's just a matter of actually doing it. But that project is going to take way more time than I want to invest right now. All right. Another challenge I had was with my fan. So fan relay runs, blah, 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 sends signal. Okay. So what ended up happening was my old setup, my fan connector broke on this. So to kill two birds with one stone, I ended up, as you can see, fitting it so that when my radiator fan turned on, my passenger blower fan slash, it's basically a radiator fan, turned on. I know it's supposed to be set up so that AC turns it on, but more cold is better, so I had it set up like that. It worked fine on the factory ECU. On the Haltech ECU, the way it's programmed and wired set, it kept on either staying on or off. I couldn't get it to just respond to the voltage, to the I wanted it to turn on at 190 Fahrenheit and then turn off at 180. I couldn't get it. So what I ended up doing is I ended up stripping back the sleeving for the relay for the blower. The thermal fan, like you saw on the software, I deleted the thermal fan 2, but I ended up reassigning that wire to thermal fan 1, which is this black and white one right here. This trips on ground and sends the 12 volt with the relay to this green black wire, which then runs to this, and then this is grounded. So then my blower relay is now my my dual fan relay. This is where I was talking about the versatility of Haltech. It's not specific to the harness or to the engine harness or to whatever I want. It's specific to whatever I decide those wires' duty responsibilities are. And I can reassign them in and off to whatever I want. Only a set wires have limitations on what they can be set to. So for instance, the drive-by wires, I have to use two certain ones. The high-low CAN bus signal, have to use two certain ones. The injector ones, those are specific. When they're specific to output for injectors, because I have 4 extras from the V8 application, I can assign them to do other things. If I wanted to, they could be running my fans. If I wanted to, I could set them to run a third fan for, say, an oil cooler or a differential cooler. Whatever I want those four setting outputs to be, I can. The same goes for the fuel injectors for those four, for the extra four. I am going to be running proper coil on plugs for all four, which is why I left the first four ignition ports open, and then the last four are for me to use however I want. The reason I let them open is because I want these guys to be coil unplugged. Um, that's basically everything that I did and had trouble with. Oh, the idle control. So the idle control on the Haltech software is super simple and versatile, but you're still limited to what this will allow. Full max on the idle control here, clockwise. The lowest I could get it is to 950 on the idle. I wanted to get it to 850, but I'm not really going to complain. The car idles really smooth. It's really nice. I can't do steady state tuning for the air fuel ratios because I don't have my own personal dyno. That's going to be either something I have someone do later down the line, or I'll just I'll just go get it tuned. But I want the drive-by-wire first. And just to explain why. So once I have drive-by-wire, all of these idle controls, idle cables, all of this, the cruise control, all of this is going to be gone. So this whole vacuum tubing system is going to be gone. It's just going to be the drive-by-wire module right there, and that's it. The engine bay is going to be very naked compared to what it is right now. My fuel pressure, I'm going to swap this out for a fuel pressure gauge sensor to run it inside so I can monitor that. I'm either going to, next time I do an oil change, I'm going to put a pressure plate, a oil plate to either get fuel temp, oil temp and oil pressure, or I'm going to switch out the factory oil pressure sensor for a smart sensor so I can see that as well. Again, the best benefit to me about this system is not necessarily just the black and white. Hey, it turns on, it turns off. It runs the car, it doesn't. It's how versatile the Haltech is. If anyone is thinking about doing this, has any questions, just hit me up, message me. I'll answer what I can. Tuning it is even actually not that hard. I started tuning the idle control and the air fuel ratios at idle. It is so easy. Honestly, if you could probably, for any application, you could probably rent out your own dyno, save on the tuner cost, and just do it yourself once you figure it out. It's very straightforward.